Question number 14. Let's solve the following SSA triangle. You have a side-side angle. You can even spell this backwards. This is such a pain. Angle, side-side. These types of triangle, spelled forward or backwards, can be a big pain because of the ambiguous case. Now this one's not so bad, question number 14, because there's only one possible answer. This triangle here is fixed. This angle is quite big. We don't have to worry about a second case because what we see is what we get. So let's try to solve this using the sine law. So let's focus on playing catch. We're going to play with this and across the field like this. So we're going to say sine theta over 4 is equals to sine of the angle over 8. Multiply both sides by 4. We have sine theta is approximately equals to 0.35355, etc. And we can hit the sine inverse button to get the angle. So one possible angle is approximately 20.7 degrees. And when you look at the diagram, that's quite reasonable. Now, whenever you're dealing with trigonometry, specifically for the sine function and using sine law, sometimes we might have to subtract by 180 to get theta 2. So theta 2 equals 180 minus 20.7, which is equals to 159.3 degrees. But we reject this because if you look at the picture visually, it's ridiculous. It's too big. But there are cases in the next question where we have to worry about this. So in question number 15, again, we're dealing with an ambiguous case. Imagine over the phone, you want a builder to build you a swimming pool, and all the person hears is, yes, angle C is 33 degrees here. Side C is 6. There's the isosceles triangle of 6. This is also 6 here. Side B is 10. So you think the person's going to build you a big pool, but what if they make the mistake of building a small pool? They actually follow all the criteria, but there's some ambiguity here. This triangle can swing from here all the way to here because this is like a radius of a circle swinging around back and forth like a pendulum. So when you're given just text without an actual diagram, angle B can be either acute or it can be obtuse. We have to be very careful here. So what are the possible angles of B? So in this case, let's just use the sine law. So let's play catch across the angle B here. We'll say sine B over 10 is equals to, and play catch with 30 degrees, 33 degrees and 6, sine 33 degrees over 6. Multiply both sides by 10. We have sine B approximately 0.9077. Hit the sine inverse button and we get a possible angle for B, which is 65.2 degrees. Now be careful, that looks quite reasonable for the pool that you had in mind, but always remember to take a second possible answer, which is 180 minus this result, which is approximately 114.8 degrees. So you can see that this here is a straight line, 180 degrees is flat, and when you subtract this 65.2 angle here, you get the leftover, which is this triangle over here. So because of the ambiguous case, you might be quite upset having a very small triangular pool. So now let's find the possible side lengths of A. Let's focus on the big triangle first. The big triangle looks something like this, and this is A, this is capital A, this is 6, this is 10, 33 degrees. So in this case, angle B is acute. It's 65.2. So it's good to keep the digits on your calculator. And let's play catch. this mystery angle A is going to be 180 minus 33 minus 65.2, which is approximately 81.8 degrees. And so now we use the sine law to calculate A. A over sine of A, and this mystery angle we calculate as approximately 81.8, is equals to 6 over sine 33. We could have used the 10 and the 65.2 degrees as well, but it's better to use numbers that are not calculated. Multiplying both sides by sine 81.8, we get A is approximately 10.9. Okay, so now let's continue this problem and focus on the other possible triangle. So instead of the acute angle B, let's focus on the obtuse angle B, in which B is calculated at 114.8 degrees. So this diagram is not to scale, but we have 6 as a side length, we have 10, and we're also given 33 degrees. Let's figure out this mystery angle here. It's 180 minus 33 minus 114.8, which is approximately 32.2 degrees. Alright, so now we should be able to figure out the shorter version of A here by playing catch. So A over sine 32.2 degrees is equals to 6 over sine 33. Going this way here. Multiply both sides by sine 32.2. We get A is approximately 5.87. Okay, now it's your turn. Given angle A is 29 degrees, C equals 18 and A equals 17, solve the two possible triangles. Solve the side lengths and angles.